I just want to go through a few of the answers on the worksheet. Most of you checked them in class. Things to make note of. Oftentimes, you can rewrite your final answer as a factored form. You check the other problems from the book, that's similar here. The reason we write it in a factored form like this is at some point you may have to set this equal to 0 and solve it. And so it's easy to solve here. If you did set y prime equal to 0, you could get -3 and 0. So that's a helpful thing to have. I'm just going to show you some of the answers here. Again, use your product rule. E regenerates itself, so it ends up being something you can factor out. Quotient rule here. This one involves natural log and E both. So that means when there may be a time where something cancels out. Some people ask me about this one. Number 9 is a chain rule. If you look at it, 3u squared. So 3 times our function to the second times the derivative of the inside. Not really anything you can combine at that point. And they don't get much different. I think number 12, there's one like this in the book. It's a little easier if you write it as a quantity, and then you can do the chain rule as well. And number 13, you definitely want to break it up first, and so the derivative is to here, and then I went ahead and simplified it because we need more practice at doing that, whether you like that or not. Because again, you can solve this. This is not solvable. This one is solvable. You just set the denominator equal to 0. 14 is product rule. And then 16 is an application, so implicit differentiation. Get dy dx by itself. And 17, there's a product rule for the second part. Be careful with this minus. It needs to be on both of them. And I'm going to leave this up here. So process of extrema, find the derivative, set it equal to 0. You can never get a power here that's going to make an exponential function 0. You can't raise an exponent to a number that gives you 0. You can make it close to 0, but it's never going to get to 0. So if you look right here, what I did is when I found the zeros, which are pretty easy to find, you have to test them. And so I showed you what value I tested at. So right here I tested y prime of -10, and this is what it looks like, which is positive. So you can see where your mins and maxes are at. You may have to pause this video to take a look at as you work through some of those. But all you're doing is finding the derivative, set it equal to 0, find your critical numbers, put it in a table, test your critical numbers. Same process as always. For the integral of e to the x, the initial ones, we did some of them in class, but you start out, the easy ones, you let u equal the exponent, and then it starts to get a little more complicated. Always try out by letting the u be the exponent. On number 4, I rewrote, because I knew that the derivative of tangent was secant. So you can rewrite this as secant squared, and then stuff will cancel out. I think it's easier on number 5 to multiply everything out. Number 6, pretty straightforward, power rule. 7 is not bad, but you get a little googly-eyed with all those e's and positives and negatives. Number 8, critical to note here, there's a monomial denominator, which means you can split this up into 3 fractions. E to the 2x minus e to the x, because it's dividing, is e to the x. E to the negative x, if you move this up, now you have e to the -2x. These are all ones that you can integrate without writing anything, probably at this point. On this one, we're going to let the denominator equal u, because we don't know what to do with that numerator. and you realize that the e's to the x's cancel out, and you end up with a natural log. These are not bad, self-explanatory. I'm going to talk about number 12, because you know the integral of 1 over x is natural log of x. Plugging in e cubed and 1. Natural log of e cubed is an inverse, so the e natural log part cancels out, and you just get 3 minus 0. The area of the region means you're taking an integral from the x to the x. This y equals 0 just means it's to the x-axis. So you're integrating this e to the negative x, plugging in 4, plugging in 0. Don't forget to subtract your negative, because e to the 0 is a number. A lot of times when we plugged in 0, it just went away with polynomials, but e is a number. Same thing here. Integrate first. When you go to plug in, radical 2 squared is 2, so we have negative 2 over 2, which is negative 1. And don't forget that e to the negative 1 is just 1 over e. It's like negative 1 over 2.7. So those are all the different processes. We'll work on some applications later on in class.